Hello everyone, welcome to our channel. Today we'll talk about siphon. Here we have present the figure over here related to siphon. Here, this is the tank A and this is the tank B, from where the water is flowing from the higher altitude of the tank A to the lower altitude of the tank B. So before knowing more about this, let's move to the definition of a siphon. A siphon is a simple structure or device used to transfer liquid over an obstacle, typically from a higher elevation to a lower one, relying on gravity and atmospheric pressure. While it might not be commonly referred as a structure in a theoretical sense or in a traditional sense, it does involve specific components. The main components of siphon include inlet tube, the point from where the water gets entered for the next reservoir, and the U-shaped bend or elbow, and the outlet point on the next reservoir, as well as the atmospheric pressure occurred while performing these works and principles. So inlet tube, the part of the siphon that commonly carries the liquid from higher elevation to the lower elevation. It is usually dipped into the liquid source. And U-shaped pipe, the tube dips into the and rise again, creating a U-shaped bend. These bends allow the liquid to flow over an obstacle or elevation and begin the siphoning process. The third one is outlet tube, the part of the siphon that leads the liquid down to the lower elevation. This is where the liquid exits the siphon. And the final one is atmospheric pressure. The siphon works based on the difference in atmospheric pressure between the two ends of the tube. Gravity helps initiate the flow and atmospheric pressure maintains it. The key principle behind a siphon is that the liquid flows due to the force of gravity, with atmospheric pressure playing a critical role. The siphon must be filled with liquid to start the process, and once it's primed, the liquid flows continuously as long as outlet end is lower than the inlet end. It's important to note that the effectiveness of siphon depends on factors such as height, this height and this height, difference between the inlet and outlet point, and type of liquid and the atmospheric pressure at the location. While siphons are simple and useful for various applications, they are not commonly associated with the large-scale engineering projects like hydropower, dams, etc. Now talking about the applications. Siphons are used in various applications, from simple liquid transfer in household works to more complex industrial and scientific process. But today we'll talk particularly about the use of or application of siphons in context of water-related works. For example, the siphons are used in hydrology, hydraulics, and water-related subject in our study phase to draw water from canal laying to outlet, as well as to empty the tank having no any outlet, and to supply water to town over a bridge. And it's most effectively used to connect two reservoirs. You can consider this one is the one reservoir and this one is the another reservoir in our context. So to connect two reservoirs at different levels separated by a mountain. Here we don't have separated any by mountain, but let's consider this one is one reservoir and this one is another reservoir at two different elevations. So to connect two reservoirs at different levels separated by mountains or valley or any other obstacle. In such case, it is mostly applicable. For the calculation, today we'll find out the value of this head difference and this head difference. So let's start by using Bernoulli equation. PA by gamma plus PA square by 2G plus ZA equals PB by pressure at B plus velocity B square by 2G plus ZB plus head loss. When if PA by gamma plus PB by gamma equals P atmospheric by gamma and PA equals PB is equals to 0, then head loss equals ZA minus ZB equals H. That is HL is equal to head loss, where head loss at entry equals now HL equals entry plus head loss due to friction plus head loss at exit. And this means the head loss at entry is 0.5 times of P square by 2G plus head loss due to friction FLV square by 2GD plus head loss at exit V square by 2G. It means H equals this. For the calculation of capital H, it means height from the water level of top reservoir to the water level of bottom reservoir. Now calculating the height above the water elevation of top reservoir to the summit of the bend. It means now calculating the height from this point to the summit point, water elevation from the top reservoir level to the summit of the bend. For this two, applying Bernoulli's equation and summit, PA by gamma plus PA square by 2G plus ZA equals P summit by gamma plus P summit square by 2G plus ZS plus HL head loss, or PA minus PS by gamma equals P square by 2G plus Z summit minus ZA plus HL. Now H equals PA minus PS by gamma minus P square by 2G minus 0.5 V square by 2G plus FL P square by 2GD, where HL is the head loss at entry and frictional loss at the summit, which is not the exit point. At the summit there is no occurrence of the exit, only the friction occurs and entrance occurs. So HL is equal to head loss at entry plus head loss at friction. ZS minus ZA equals H. The value of ZS minus ZH is A, and PA minus PS same, where this equation is V square by 2G and the value of this is this, and ZL is equal to head loss at entry summit. By this two equation, this is equation 2, this is equation 1. So by using these two equation, by using this equation and this equation, we'll find out the head of the siphon. So thank you for today. We'll come again with one new video. Till then, keep on watching our channel and don't forget to subscribe us. Thank you.